Howdy folks, I just wanted to talk to you today about a great resource we have that we can lend out to your classes and we can give you support on, called b.Boards and microbits. Some of you may have heard of it before, but they're really great kits that you can use for your students to become makers, to create all sorts of things from robots, out of cardboard, to light displays, to wherever their imagination takes them. So I was just going to do a quick demo of what this can do. It's Christmas time around here right now, so I'm going to make a cardboard waving Santa with a bit of Christmas spirit and lights. Alright, so let's dive on in. So first I just print out a Santa, color it in, get some cardboard. I'm going to attach Santa to the cardboard just to give him some more structure, and then I have his arm that's going to be separate so it can wave. So I grab my b.Board, which is like a computer that's run by a microbit. So that's what the microbit looks like. We're going to program the microbit, but first we have to attach it into our b.Board. So once we've got it in, we now have to attach a USB cord to our microbit through that port so that we can upload instructions from the computer. Now we've got the lights running, we know it's good to go. We hop into the coding. So it's through Brilliant Labs. So we have version 1 of the microbit. So we're gonna start that project. And now we have, so now we're gonna mess around with our LED lights. They're called NeoPixels. So I'm going to set that in so that on start, it's going to be set, and we have 24 LEDs in this light switch, so we'll have to add that in. So we'll change that to 30. And now we're going to have to change a color, choose a color for our NeoPixel. So it's Christmas time, so you can do rainbow, which is kind of nice, but I'm going to do the color red. So I'm going to drag that in and pop that underneath set strip to. So we put it in, and I'm going to leave it as red. So now I have to connect my NeoPixel. So I'm going to connect the white to the P2, and then I connect power and ground, and then I plug the battery pack into the b.Board so it can actually run the lights. So now I have to set the pin to P2 where I put it, and now if I hit download, it should work. So first I had to pair my microbit to my computer so I can download instructions to it, and now, boop, we have red lights. Okay, so we connected it to pin 2, so now let's do green. So I take the white, I'm going to connect it to pin 13, P13, and then I have to connect red, which is power. I'm going to connect that to the power section so the lights can receive power, and then the black is the ground, so I'm going to attach it to where the ground symbol is, and now we're all hooked up. So once again, I'm going to take strip 2, I'm going to drag that in there, and then I'm going to say show the color, and I'm going to switch from red to green, and then I'm going to set it to pin 13, which is where I set it up. So if I hit download, all of a sudden, boop, now we have green and we have red. So now we're getting festive. So we've got the lights taken care of. Now we're going to use this servo, which has the ability to go back and forth or around in circles. We're going to attach this arm to it, and we're going to program it to go back and forth in a waving. So we're going to plug in our servo to P0 in those pins right there. And now we can program it. So there's different heads you can attach to your servo. I'm going to go with this one. It's the best one for waving, and I'm going to attach my arm to it. So we stick it on there, and I'm just going to use the screw to help me a little bit and screw it down through the cardboard into the servo to attach it. So now we want it to wave. So we're going to go to the servo section where we want positional. So we're going to hit set servo to an angle. So all we're going to do is tell it to change different directions. So we're going to start with a high angle, and then we want it to go back the other way. So then we'll say, well, then set it to this position. So we're going to go for a smaller angle, so it goes back and forth between 150 and 158. Now if I was to hit start right now, it would immediately go back and forth trying to go from 150 to 58, but it can't do that because it's going to be instantaneous. So we have to choose pause from basic. So we want it to go to one position, pause, we're going to say 700 milliseconds, and then we want it to go to the other position, and we'll duplicate it because we also want it to pause there. Because it'll immediately try to go back. So now we have pauses between, we can download, it'll go one position, pause, other position, pause. 700 milliseconds is 0.7 seconds. So you can see we're going back and forth. Now it was a little loose, so the arm was falling off, so I had to tape it on to get it a little more structure. And so we tape on our arm, and then we tape the servo to the Santa, so now it's all connected. Now I have this lit up Santa who can wave, ho ho ho. He can have it play music, lots of things. So I wanted to get a little interesting with it. There's lots of sensors, so I chose this IR brake beam, which is the same type of sensor that stops your garage door from closing on you. It's a little infrared sensor that shoots across. And I wanted to make it so that if, you know, it has some sort of motion sensing, that it can make it behave differently. So I use this IR brake beam, and I say when it's closed I want it to show rainbow and I want it to wave, but when it's open I want it to show just red and green lights. So you'll see as I move the sensor around, it changes the lights between red and green and rainbow. So here I'm holding the sensor, I'm walking by, and it's activating the Santa to wave at me. And then you can see here it really shows the ability of the brake beam. These weren't the strongest in the world, but they were able to demonstrate kind of how it works. So when it goes rainbow, the Santa is waving. So there's just an example of a quick activity I did. The fun thing about this is you give it to students, you give them a design challenge, you give them an idea, but then you let them problem solve, you let them create what they like. There's tons of different projects you can use, and students are able to come up with things you never even thought of. So, and it's really great for the problem solving aspect. Like I had a hard time with those IR motion beams, but you know, I figured out something that could work. Now with the stronger IR motion beam, I could have done more of what I wanted to. But there's a great resource. We have 7 b.Boards, so you know, plenty for a class where students can work together to create something fun and learn a bit of coding and design. So hit us up if you want to borrow or check out the b.Boards. All right, thanks.
Alrighty, so let's have a look inside this case to see all the goodies we have inside. So start off, we have 24 rechargeable batteries that are useful in some battery packs. We have 7 of these b.Boards that are, so you can use them in groups. These are the computers that'll plug everything into. Then we have 8 of these light strips that are programmable with 30 lights. We have 7 of these rechargeable battery packs that are used to power the b.Board. We have 6 of these USB connectors to plug them into the computer. We have 7 of these battery power supplies as well. We have, these are the microbits, and then we have 8 of those. We have a whole bunch of these alligator clip wires. We have 7 of these to charge up our battery packs here. And then on the other side, we have 25 servos. Well, this is the 2 of these IR sensors. These are 25 servos for powering and moving. We have 16 wheels. And we have 16 motors that can power those wheels. So you can see here, using all this stuff together, you can put a lot together and build. And it comes in quite the nice little carrying case, so you can pack it up and wheel it around wherever you need to take it.